General statements. Is it true? What is it? A statement that is about particular examples and is a rule that always works. Why? Builds critical thinking skills. Interesting fact. Tigers regularly hunt alone. Usually less than 10% of hunts are successful. Vocabulary. General statement is not about particular examples and is a rule that always works. And then counterexample is an example that shows a general statement is wrong. When you're proving it to be false, you just need one counterexample, and for a general statement, you need three or more to prove it's true. So let's go ahead and take a look at the steps. Step 1, find the important information. Step 2, do a few examples to check. Step 3, write true or false, and if false, you need to write a sentence. Let's go ahead and take a look at the first example. Every time you multiply a number by 10, each digit moves one place value to the left. Now when you're doing examples, you just pick some random number. Pick your favorite number. I'm going to pick 45, and then we're going to multiply it by 10 because that is the important information. We're going to get 450. So now we're going to go ahead and prove why this is true. Even though it's true, even though you pick a number and you did it, you still have to prove why it's true. And here's the place value chart. So let's put 45 in there. Let's start with the digit of 0 and work our way left. So now we can realize that the 5 went from the units to the tens, and the 4 went from the tens to the hundreds. So in this case, it is true, but unfortunately, we need more examples to prove it is true. So let's do one more because that's all we have room for. And let's go ahead and pick 134 because it's a 3-digit number. We're going to multiply it by 10. And we get 1,340. And let's use the place value chart to go ahead and prove why it's true. And then we have 134 in there. Start with the units of value of 0, work our way left, and we can say the units of the 4 in the units goes to the left to the tens, the 3 in the tens goes to the hundreds, and the 1 in the hundreds goes to the thousands. So in both of these cases, it is true, so we can say that this general statement is true. So let's take a look at the example 2, and I would say every number whose units digit is 4 is a multiple of 4. So what's the important information here? Units digit and multiple of 4. So let's write down the multiples of 4. And once again, pick any random number. So in this particular case, I'm going to pick 24. But once again, you have to prove why it's 24 is or is not a multiple of 4. So we can say 24 is 4 times 6, which is 24. So therefore, 24 is a multiple of 4. But once again, you need more than one case for it to be true. So let's pick a 3-digit number, 144, and we can rewrite 144 as 4 times 36, which is 144. Now, just when you're doing some of these, sometimes you don't just pick a random number. Make a random number with thought. Okay, 144 is a 3-digit number, but what is an even easier 3-digit number than 144? 400, because that is an even easier 3-digit number that is a multiple of 4. Wait a second, I just remembered something. Let's talk about 34. Okay, if we look on the left of the multiples, it's not there. So let's prove why it's not. So 4 times 8 is 32. 4 times 9 is 36. And there's no whole number times 4 to give me 34. So therefore, 34 is not a multiple of 4. And we can say that this general statement is false. Now, sometimes you get lucky and you find your counterexample in your first case or example, and then you're done. But other times you get unlucky and you find it in the second or third case or even higher. So once you find one, you're done. And there's an infinite amount of cases for to prove that is false. So let's go ahead. So for instance, if you thought of an easier one like 14 before you did 24 or 144, then great, then you're done. Okay, now, but we still have to write down the sentence and say it is false because 34 has 4 in the units place value, but is not a multiple of 4. So let's go ahead and take a look at the last example. And the sum of two even numbers is always even. So the important information is even. So let's go ahead and write down the definitions of even. Is a multiple of 2 or is divisible by 2 without a remainder. So let's go ahead and write down the multiples of 2 so it's a little easier to see. And then we're going to pick one-digit numbers to start with. And we get 2 plus 4 is 6. And then 6 is a multiple of 2 because 2 times 3 is 6. And next, we're going to pick two-digit numbers. So 12 plus 24 is 36. 36 is a multiple of 2 because 2 times 18 is 36. And then finally, we're going to pick three-digit numbers. So 140 plus 108 is 248. And 248 is a multiple of 2 because 2 times 124 is 248. So we picked a wide variety of numbers, and we picked, so therefore we can say that this general statement is true. So now it is your turn. So before you do that, remember general statements need 3 or about 3 for you to be true, and to be false, you only need one counterexample. So go ahead and pause this video so you can take your time to answer these questions, and I'm going to show you the answers in 3, 2, and 1. Here are the answers. Let's take a look at example 2 real quickly. You can have any counterexample again. So if you found that it is false and you have a different counterexample than mine, that's perfect. It still works for it to be false. So if you got all 3 of them correct, well done. If you didn't, then there's always tomorrow.